Alright folks, today is our first day of Chapter 10, which we will be talking about trigonometry. Okay, so trigonometry is a part of geometry where we really focus a lot on triangles. Okay, so today's just an introduction about specifically right triangles and the different parts of each of them. Okay, so here we're given right triangle ABC, so let's go ahead and mark our right angle. We know some things already. We've got three different pieces here, the opposite side, the adjacent side, and the hypotenuse. Okay, hopefully you know the hypotenuse has to be the side across from the right angle in the picture. Okay, so we're going to start with the definition there. Okay, it's the side across from the right angle in the triangle. Okay. Now when we're dealing with the right angle, it's also the longest side. Right? So that one is very clear. Then we've got these opposite side and adjacent side. Both of these words, opposite and adjacent, are compared to something. And what they're compared to is one of the other angles in the triangle. Now we've got a right angle. That means there's only 90 degrees left to work with between the two angles. So our other two angles in the triangle are acute angles. So when I say the opposite side, I mean that the leg across from one of those given acute angles. They have to tell you which angle they want you to focus on, and then we pick the side across from it. All right. Well, say for example we're focusing on angle A here. The side across from it, okay, is actually the side that doesn't touch it. Okay, so that's another way to look at it. Does not touch the angle. Then the adjacent side is the one right next to, but is not the hypotenuse here. Okay, so it is the leg that tells us not the hypotenuse that is next to the given angle. Okay, so touches this time, but not the hypotenuse. Alright, so down here below, we're going to go identify the sides of each of these based on where they are. Okay, we should always start with the hypotenuse because that's what we're most familiar with across from the right angle. We can name a side in two different ways. We can use the capital letters at the corners or the end points of the segment. Okay, so we could call this BA with that segment symbol on top, that little hat. Or we can use the lowercase letter because they're there in this case. They won't always be. And call it little c. So there's our hypotenuse. That will never change. Now, the reason I said that won't ever change is because these other ones will. Based on which angle we're focusing on, the opposite side isn't fixed for every single triangle. It's fixed for a given angle. Okay, so we're going to focus on A first. What I want you to do is put a little angle mark at A. And we want to do the opposite side. So there's two sides that touch angle A. We want the one that doesn't, straight across from it. And that is BC. Or we could call that little a. Then the adjacent side is the side that's left, essentially, but it's the side that touches it on the bottom here because we can't use the hypotenuse. So AC or CA, either one is fine. Then we can call that lowercase b as well. For the next part, we're going to concentrate then on angle B. Okay, so now we're up here. And the opposite side, directly across from, doesn't touch the angle. That's AC. Again, you can call it CA if you want. Order doesn't matter on that. Or little b. Then the adjacent side is the side that touches it right on that angle, but not the hypotenuse. And that's BC. Or little a. Okay, so for each of these next problems, we're going to do stuff like that, identify the opposite and the adjacent side. But then on B, C, and D, we're asked to find the ratio or the lengths of each of these sides. Okay, so all of these ones should look like numbers. Then part A should look like the sides using 2 capital letters. Notice it says label the sides as segments. That means 2 letters with that symbol for segment on top. So starting out, we're focusing on angle A. Let's mark the hypotenuse across from the right angle so that we don't use it to answer these questions. It says side opposite angle A. So across from angle A, CB. Then adjacent to angle A, right next to it, not the hypotenuse, so that's AC. Now, part B asks for find the third side of a right triangle. Okay, remember to do that, we need to set up Pythagorean theorem. If you know that your numbers are part of a Pythagorean triple, then you can go ahead and just write down your answer. Otherwise, you'll have to do this work. So we've got 36 plus 64 equals x squared. 100. This one comes out real nice, and we've got that being 10. So our length of AB is 10. Notice here it has AB without that hat. That tells you it's looking for the length. Okay. Now we're going to find the ratio of 2 sides. First it has BC on top, so in our picture BC is the number 8. And then AC is the number 6, so 8 over 6, and we just have to reduce that. 2 goes into both of them, so we can call that 4/3. Remember, if you struggle with fractions, your calculator can reduce these for you. Just make sure you write it as division and then change it to a fraction. Last thing, just wants the length of the hypotenuse. The hypotenuse in our picture was this 10 that we saw for. So B and D ended up matching up. They will not always in this problem because the missing side from part B does not always have to be the hypotenuse, so be aware of that. Over on number 2, side opposite angle B. So we're focusing on angle B this time. Again, we want to mark the hypotenuse across from the right angle. So we don't use that for this. And then opposite will be over here, not touching that angle B, CA. And the adjacent one touches but is not the hypotenuse, so that leaves us with BC. Our missing side is the hypotenuse again, so we're setting up 8 squared plus 10 squared equals x squared. And then 64 plus 100 equals x squared. We want to now take the square root of 164. That's not a perfect square. Okay, so just type that in your calculator. Our work this chapter is going to be useful for us to look at the decimal version versus the broken down simplified radical. Okay, so we just want to write this as 12.8. Now the ratio, BC in our picture, so BC was 10. AC, start at A, follow it to C, that's 8. And then once again, we always have to reduce when we're working with a fraction. So we've got 5, and then we've got 4. The length of the hypotenuse, that was our missing side again, so that is our 12.8. Okay. Right now, I want you to pause the video and take care of number 3. Pay attention on part B for this. Your missing side here is not the hypotenuse, so be careful when you set up Pythagorean theorem on this one. So for this one, opposite is SR. If you have RS, that's okay. Adjacent QR or RQ. The missing side is 12. That is a Pythagorean triple, so if you know it, you can just write it down. Otherwise, make sure you're writing something so I can see where it came from. And then our ratio, RS was that 12, then divided by 5. This time our fraction didn't reduce. Sometimes that will happen, and it's okay. Hypotenuse was different from B, since we weren't solving for that. It is just 13 in the picture. Last one here has a couple different things that's interesting about it. First, in part A, you'll notice they're choosing two different angles here. Okay, so we want the side that's opposite U, but then we want the side that's adjacent to S. Okay, so first we're focusing on U down here. The side across from it, or opposite, is ST. Then we'll switch our focus for the second part, angle S, and this time we want the adjacent one. Okay, across from the 90 is our hypotenuse. That won't change. We cannot use that side for adjacent. So that means we're only left with ST. And you'll notice our opposite side of one angle was the adjacent side of the other. Okay, so that's something interesting that happens with these right triangles. Now, ST and TU, the side that we're missing, okay, we have to solve for both of those, but you'll notice they're both equal to x. That's the only way this is going to work, is if they're equal. But we set it up just like normal Pythagorean theorem. We want the hypotenuse by itself, so that looks like x squared plus x squared equals 7.07 squared. Well, really, if it helps, this is 1x squared and 1x squared. When we put it together, we've got 2x squared. Okay, in your calculator, we're going to square 7.07. Now you'll notice if we try to round this to one decimal place, it goes up to 50. So we'll just call that 50. Divide by 2, which gives us 25. And then it comes out to be a nice number. Oftentimes, when you see a triangle that has a decimal number for one of the sides, it's because it's a rounded square root of something. Okay, so the other side should come out pretty nicely. Filling in our ratio, we've got ST on top, so 5. And then we've got UT on the bottom, 5 again. 5 divided by 5 is 1. Hypotenuse was our 7.07, and we're done. Okay. Your homework will be very similar to this. On the back, you'll notice you have some definitions. You're welcome to use the internet to help you with those. Just make sure that your definitions are math definitions and not English definitions. Okay. If you have any questions on that, come see me.